Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is arithmetic of finance. What we are going to take is the second type of interest, that is the compound interest. So let's begin. After completing the very lesson today, my dear student will be able to number one, explain the difference between simple interest and compound interest. Number two, you'll be able to calculate the compound interest. These are the two things I hope my dear student will be able to do after completing the very lesson today. So as usual, my dear student, your favorite segment of the lesson today, I'll give you another group of numbers, another very special group of numbers. And this group of numbers are called the sad numbers. This is really interesting. So numbers can be sad. I will explain what are sad numbers with an example after completing my lesson today, so don't go away. To begin the lesson, my dear student, let me also explain what is a compound interest. So compound interest, in this type of interest, the interest earned each year is now added to the account, and that earns another interest the following year. So which means if we are to find this compound interest, how it differ with the simple interest, that is our previous lessons. And the simple interest, if it says after 4 years or after 3 years, we try to get the interest all at once. That is for those total period. But in case of compound interest, we calculate it each year, and each year the interest earned will now become part of the investment or part of the principal in the next year. This is what the statement is saying. So compound interest is now calculated each year, just like I have explained, and the amount of interest generated in the very first year is now converted into a principal in the second year. What was generated in the second year will also be part of the principles in the third year, like that. We are going to take examples how we can make use of this, just this explanation in practice. So let us move and learn how to find the compound interest. So example number one, it says to find the compound interest paid on this 2,000 naira that was invested for 3 years at 10% per annum. So this is the amount invested, and this is the duration, and this is the rate. So solution to this very problem. So as earlier explained, compound interest we calculated year by year. So in this case, these 3 years, we have to split it into 3 years. So there will be 3 different calculations there. So let me just start. So the very first year, let's see. The interest in that very first year is what we are going to find first. So let's just find out what will now be our investment, our principal. It is 2,000 naira. The rate is 10%, while the time is just 1. I will just not consider this 3 years. I'll split it into 1 year each. So the time there that I'm going to substitute in the formula is now 1. So substituted in the formula, that is I equals to 2,000, that is your P, multiplied by 10, that is your R, multiplied by 1, that is your T. So this is just that formula, PRT all over 100. And simplifying this, it will give us our I as the 200, that is the interest. So in the very first year, this 2,000 naira will now generate interest of 200 naira. So if we move to the second year, this 200 naira will now be part of the principal, part of the investment. So let's just move to the second year. Second year is now says my P, that is the principal, will now be the original principal, which is now 2,000 naira plus the interest earned in that very first year. This will give me 2,200 naira. And the R is the same 10%, the time is just 1. So substituted in this formula for PRT all over 100. You now have 2,200 for P, multiplied by 10 for R, multiplied by 1 for T, all over 100. And simplifying this, if you done correctly, will give you the interest in the second year, 220. So we now move to the third year, because it's 3 years. So moving to the third year, the principal will now change. It will now be the previous principal, which is now this 2,200 plus the interest generated in the second year. So that gives me the new principal. That is the new investment. It's now going to be 2,200 naira. The investment in the second year, beginning second year, plus the interest generated in that second year, which is 220. This gives me 2,420. And substituted in this formula, that is for calculating simple interest, PRT all over 100, you now have interest in the third year as this 2,420 multiplied by 10 multiplied by 1 all over 100. And simplifying this, if done correctly, you now have 242 naira. So these are the three interests generated in each year, that is first year, second year, and the third year. The question asks to find the compound interest. So the compound interest will now be the total sum of these three interests in each different year. So let me do that. So the compound interest is now going to be the 200 interest first year plus the 220 interest second year plus the 242 naira interest the third year. Let me just substitute. So addition of this correctly gives you 662 naira. This will now be the interest that will now, this money, 2,000 will now generate in 3 years. Naira. Let's just move and take another example. Example number 2, it says Mr. John borrowed this 245,000 naira from a banker, and that the banker charges 25% compound interest per annum. And this person, Mr. John, usually pays 100,000 at the end of each year. Then the question asked here is how much is he owing at the beginning of the third year? So solution to this very problem. So as it is 2 years, we have to get the interest the first year and the second year. So starting with the very first year, so the P, the money he borrowed beginning of the very first year is 245,000 naira. The R is 25%, the time is 1. So let me just calculate the interest the bank will now get from this money that Mr. John borrowed. So interest will now be equals to 245,000 naira multiplied by 25, that is the R, multiplied by 1, that is the T, all over 100. This will give interest of 61,000 naira 250. This will now be the interest only in the very first year. And this interest will now be part of the bank's money in the second year that they will use to calculate interest in the second year. So let's just move to the second year. So the new money for the bank will now be equals to the original money plus the interest earned in the very first year, which is 61,250. Then minus the 100,000 naira, which he now paid at the end of first year. So this simplification, if done correctly, will now give the new amount that the bank will now calculate interest on it in the second year. And it is now going to be 206,250 naira. So we now substitute in the formula to find the interest in the second year. So interest in the second year will now be equals to the 206,250 multiplied by 25 multiplied by 1 all over 100. If this interest is calculated correctly, you now have 51,562 naira 50 kobo. This will now be the interest. This 206,250 will now generate in the second year. And it says how much is he owing at the beginning of third year. Beginning of third year means at the end of the second year. So this is where we are going to stop. Only we now find the interest. So amount to pay, that is amount that the man will now pay the bank, will now be equals to, that is the 206,250 plus the interest in that second year, then minus 100,000 because he also paid this 100,000 at the end of this second year. This is beginning of third year, which means he must have paid this maybe by December 31st of that year. Now we are talking of January 1st in the subsequent years. So when you simplify this, what you now have is what the man will now still pay the bank at the beginning of the third year. So he's now going to pay 1,507,812 naira 50 kobo. This is what the man will still pay the bank at the beginning of the third year. With this, I have come to the end of this very lesson, my dear student. I hope with the few examples given, you'll be able to calculate compound interest. Thank you for your attention, and let me just move to the last segment. Maths is fun, and explain what are certain numbers. To explain what are certain numbers, just to consider this very sequence. This is a sequence where after the very first term, each other term is obtained by sum of the squares of the digits in the previous term. That is to get the second term. Your very first term, you look at the digits in that very first term. Find their squares and add the two results. Whatever you have will now be the next term. So let's just construct or form this sequence. So if I start with this number 29, you can start with any number, any number. So starting at this number 29. So if I want to get the sequence, what I'm going to do, starting with 29. So I'm going to now find the square of 2, find the square of 9, and add the two results. So 2 square is 4, 9 square is 81. If I add the result to 4 and 81, it will give me 85. Next term, I'll find 8 square and 5 square. 8 square is 64, 5 square is 25. If I add the two results, it gives me 89. Next term, 8 square plus 9 square. If I do it correctly, it gives me 145. And next, I'll find 1 square, 4 square, and 5 square. I'll add the three results. If I do it correctly, it will give you 42. Next, I'll now find 4 square, 2 square, add the two results. It will give answer 20. So you continue the same process, adding the square of the last, that is the square of the digits in the last term. It will give you the next term. So if I continue, I'm going to have 4. The next term is now going to be 16. The next term, 37, 58, 89, 145, 42, 24, 16, and so on. So if you look at this sequence carefully, you can see there will be a repeating group of numbers, group of terms. And this group of terms, look at them, is this from this 4, the moment you get to this number 4. So this numbers 1, 2, 3, 4, 5, 6, 7, 8. These 8 numbers, you now keep repeating them. If you continue this sequence, you can see this 4 to 20. It also starts again 4, 16, 37. If you look at the pattern, it's the same pattern. So if I continue, I'll get up to this 20, then it will repeat again, it will loop back. So this numbers, this is repeating terms, that is from 4 to 20. These are the repeating terms we have. It is this group of numbers that we call certain numbers because they doesn't allow the sequence to continue. So it keeps looping and looping. And I'm telling you, if you use this criteria to form the sequence, whatever number that you start with, you come somewhere across these certain numbers. They don't want the sequence to continue. Thank you for your attention. We'll see more of these things in mathematics in our subsequent lessons.